the effects could be quite a bit larger on your organization than just the energy. I want to talk a little bit about the difference between power and energy. This is something that seems to confuse a lot of people. And what we mean by power is it's an instantaneous value. It's the speed at which your building is moving with respect to consuming energy. So right now, this building might be using 500 kilowatts. So notice it doesn't have hours on it. It's a rate, and it gets multiplied by hours. So if we're instantaneously using 500 kilowatts in this building, and we operate it for 10 hours at a constant rate today, then we're going to burn 5 megawatt hours of power. So you just multiply the hours times the kilowatts to get kilowatt hours. So energy is the whole thing. It includes the rate plus or multiplied by the hours. So I don't do a very good job explaining that, I don't think, but I hope you got something out of that. And I've got another slide on it here too. There's a simple analogy with a speedometer and an odometer in a car. So on the left here we have a power meter. So as we're consuming power, this needle shows the real-time use. So if it was on 40, this meter would be consuming 40 kilowatts of speed. That's analogous to the speed of 55 miles an hour over there. Now the center dials are how much energy used. So that's energy over time. And it's analogous to the odometer. So these dials never go backwards. This one can go up and backwards, up and back all day long. But these never go backwards, just like the odometer never goes backwards. It just continues to increase. And that's what gets read every month by your power company. This is one of our electric bills. I was going to ask if anyone wanted to guess how much we pay in electric a month, but I gave away the answer here. This one's like $1.2 million for the month of August in 2009. So we have a lot of stuff going on in this bill. How many of you know what kind of rate structure you're on in your facilities? Anybody know? Anybody on time of use rates? No? Okay, we're on this particular account here is our main bill in the main campus, and this is a time of use rate. So this, we have to be conscious of both the energy and the power. Remember, we talked about the difference of it just there. We have to be conscious of both here, and we're getting charged for both. So depending on the time of day, it's we're either on peak demand or we're off peak. And if we're on peak, we could be paying as much as twice as much for our kilowatt hours as we are off peak. In our case, it's almost exactly double. And so it's really important. It becomes important for us to really understand that. I met with somebody yesterday, actually, and he told me what was happening in California, that it's PG&E actually in California, that one of their commercial rate structures went from their base rate is 18 cents a kilowatt hour, where we're in Orlando, we're paying about 9 cents or something like that. Theirs is 18, it's double. But on peak, they're paying $1.18 in PG&E territory, which is in Northern California, Southern Washington, between Washington and California there. And so $1.18 a kilowatt hour that's a kilowatt hour, not a kilowatt during that time. So there's also a charge for the power. That's a separate charge, but that's that's 6 times different. Ours is right now about 2 times different. So whatever starts in California comes to us a lot of times, all too often. So we're keeping a closer eye on that, what we're using during peak times based on that. Oh, I forgot to tell you, you're going to have a test. When we talked about the power and energy thing, whatever, this is kind of a test. So out of this, what can you control in this slide? Anybody have an idea? Pretty simple test. And yeah, exactly. So that's all we do. The dollar thing ain't supposed to show up. Huh. That's not working right. Anyway, going back to that.
We can do that if you spin your meter back.
Yeah. Yeah. So how do we change this one right here? What do we do? What's that? And how do we do that? What we're talking about today. Yeah, more efficient equipment. Very simplest thing in your home, take out your incandescent bulb, put in a CFL or something like that. You know, that's a really easy way to understand that one. And then the hourglass, how do we change that? change that by adjusting time clocks or adjusting schedules or just turning off the lights when you leave your office at a minimum. So that's all we have control over. And that's actually a really simple concept, but you'd be amazed how many people don't understand that. So I always try to go back to that when I'm presenting to our administration, things like that. I always try to go back to what we really can do and what we can't do. You know, we don't have control of the rates, and we can't really control the bill because the university is growing and such. So here's an example of what you can do. I talked about putting in those bills, your monthly bills, into something like Excel at a bare minimum. This is an example of an analysis from Excel that we did on a building before we were doing more sophisticated analysis. And we still do these, actually. So the current year is the blue up at the top, and the previous 12 months are the bottom. And I would encourage you to look at the minimum of 24 months. I think that the Energy Star program only requires about 12 months, but I would really encourage you to if you can find that data, it's really important to look at least 24 months. You can really find some trends that don't show up so much when you're looking at 12. And why is that? Because we have a year cycle. We have a year solar cycle, right? We have 4 seasons, and we don't want to be comparing one season with a different season. We want to compare same season to same season kind of thing, is to try to normalize the weather a little bit. So what's going on in this building? What would be a possibility there? And we got a pretty constant increase the whole year. I would say either a change in rate, a change in the base rate from the power company, or a significant change in the operation of the business. Maybe they changed their hours of operation or something like that, and they've added a bunch of hours. And but it seems like it's something that could be found out, pretty easily. What about this one here? Anybody have an idea what we would what kind of red flag would this raise? What would you? Yeah. What caused that?
Turn the heat on.
It's possible. Yeah, it's possible. But you would think that January and February would have had maybe more heat than March, in most years. I'm thinking it's a billing error that would jump out at me as time to call Progress Energy or whoever your utility is and say this is not normal. Show them this graph, and this normally is enough justification to get that kind of error reversed. In a lot of cases, we do this, and we're very successful at getting them to reverse their billing. Here's a more sophisticated baseline. Now this, we're looking at trying to find a variable that's dependent on the energy data. So this one is outside air temperature, and this is something that we found the most success with in our environment, and I think you'll find the same kind of thing if you're in Central Florida, that you're going to find a real dependency on outside air temperature. So the bottom axis here, we have outside air temperature. So, and each diamond represents one day in the life of the building. So on one day, it was an average of 70 degrees outside, and the building used whatever 8,500 kilowatt hours during that day. So we plot as many of those diamonds as we can, and we try to look for a relationship. And how we know that we have a relationship is that this line is not horizontal or vertical. That's important. If we have a slope to that line, then we have some kind of dependency between the two variables. Now this variable down here, if you were in a manufacturing plant, it would most likely be the number of product going out the door kind of thing, or the number of raw material going in. If you're in a hotel motel, you might be able to apply occupancy to that as a dependent. So you might want to play with various kinds of variables down here to see what your best relationship is. And once you get a relationship like we have here, then we do a linear regression through that, and we generate which all can be done with Excel real simply. It makes that solid line, and we get an equation for that line, and that's what we call our baseline at that point. And this is actually a process that is used by energy services companies, people that are real professionals in that market where they guarantee savings. You all heard of performance contracting, I'm sure. Those professionals that do that kind of work or whatever, this is the kind of analysis they're forced to do to document the savings because they're borrowing money to do projects and things like that. So this is the level of detail that they have to look for. So this is what we choose to use at UCF, just so that we don't have anyone come back and question our analysis later on. We really go through a lot of work to make sure that we don't have questions asked of us later. And once that's done, then we work our project, right? So this is all pre-project stuff. This is up until the day we start working in the building. Then we have a period of time when we're working the project, which we call our project time, and we throw that away. We throw all that data away. After the project is done, then we start collecting data again. So the exact same thing, exact same axes, the same outside air temperature versus a different energy consumption. And we generate a new line. Now these is more scattered. This is not nearly as tight a group as that one, and we'd like to be a tighter group, but when we looked, I went and looked at what these individual dots were, these outliers, and they were things like Christmas and some holidays and other holidays, and then I think the lower ones were the weekends. Anyone have an idea why those high outliers there might be like Christmas and Thanksgiving?
Because the building's closed and you gotta use more energy to heat them.
Exactly. Because it's cold outside. The electric heat comes on because it doesn't have all the bodies in the building to keep it warm. And we're actually heating. So that immediately lends us to what do we need to do? We need to tighten up the unoccupied times. We need to look at holidays and things like that and take advantage of those times, because there's no reason to be running that electric heat if the building is empty, kind of thing. So that's some of the additional benefits we can derive from this kind of analysis. So I want to talk a little bit about Portfolio Manager. I'm not an expert at all on that. I know we've got other training going on that. There's some webinars available. But real briefly, the Energy Star not only allows you to do energy, electrical, and gas and things, but it also looks at your water consumption if you choose to input that data. And so we have several buildings in the system now. And we actually have a new software package that allows us to automatically upload to Energy Star. So we're looking forward to getting a lot more of them up there. The problem for us with Energy Star is that they don't cater to university buildings very well at all. They only have a couple of categories that we can fit some of our buildings into. So we're ending up putting them in anyway, even though they don't fit into a category. And we could still use the tool. It's just that we can't really compare ourselves to other facilities around the country, and that's some of the real power of Energy Star. So after you get your data in there, I encourage you to do 24 months, like I said, if you can find it, but only 12 months is required. They will give you a rating if you fall into one of these categories, and one of their categories, and then they will give you a carbon footprint, and they can really help you. There's a lot of other software tools available on the website, and there's a lot of really detailed energy management techniques in there that I'd encourage you to really spend some time on their website. Really good stuff. So these are the categories that they offer right now. And for us, you can see all we have is we have one building that we consider office space, predominantly office space, and we've got a bunch of residence halls, I guess. But otherwise, we don't fall in there, unfortunately. K through 12 is a really good one, though, that I work with a lot of those people on their facilities, and that's something that's been very useful to those people. So I encourage you, if anyone has a school, to really use that. But I think most of you probably fall into these categories. It's just that we're the oddball out on the university, and I'm not sure why that is. I mean, some of it is to do with all the different kinds of things going on in universities, but I don't know. I think that's a cop-out. I think they really need to get more involved in the university stuff. So I'm working with them more, trying to get more of that done, more categories.